Welcome to Brain Vision.
So since we know that y equals x squared plus c squared, we're going to move things around a little bit. So how we're going to write this is now that it's f of x, z, g of x, z, or y of x, z. So as a result of that, this will change. If we make it g, we'll make it dg dx and dg dz. That will change things slightly. And then we know that that is going to be y squared. This is going to be y squared z squared. And then inside here, once we evaluate these partial derivatives, we'll end up getting 1 plus x squared plus z squared over x squared plus z squared, which will just give us 1. So all of this will eventually just become the square root of 2, which we can move outside. That's what we'll have as a result. Then we know that y squared is x squared plus z squared. So we'll replace it with that, x squared plus z squared. And then since we know that the region, D is the region inside the circle, x squared plus c squared is less than or equal to 5 squared, we can change this into polar coordinates, where it's a circle 0 to 2 pi, and the radius is from 0 to 5. And that means that x squared plus z squared becomes r squared, and then z squared becomes r squared sine squared theta. And then instead of dA, now we'll have r dr d theta. But in this case, the r will go here, so we'll end up getting r to the 5th and dr d theta. Then we'll move this sine squared theta and make this portion d theta. We can evaluate these integrals separately now. So we'll get, as a result, square root of 2 times this integral times this integral. And what we'll end up getting is 15,625 pi times the square root of 2 divided by 6. We see we get the same answer, which is confirmation to us that the integral was calculated correctly. And this will be our final answer once we evaluate these properly.